Hi everybody, good morning. I'm doing TryHackMe OWASP Top 10 2025 Insecure Data Handling, LearnBot A045 and AA08 as they related to insecure data handling. This is related to OWASP Top 10 2025 IC1. You can see them so doing the crypto. The injection and software and data integrity failure. This is RC1 list, and you can see the changes that happened in between 2021 and 2025. And you know, always they tell you in interviews what's OWASP top 10. Maybe you can start memorizing broken access. It seems is always in the first. Security misconfiguration, software supply chain, crypto injection, insecure authentication failure, software and data integrity failure, login and altering failure, mishandling of exceptional condition. Okay, this room is more concentrating in three parts. We have three labs, small labs. We have an XOR lab. We have injection showcase. This is a Python pickle. Then we have integrity lab, insecure deserialization. Now this is the pickle. And what is this one again? This one ginger. Okay. Okay. This is it's a free room, so everybody can do it. So it's a free room. This room will introduce you to three elements of WASP Top 10 List 2025. In this room, you will learn about the element relating to application behavior and user input. We will cover this vulnerability briefly, so this is just a brief introduction. We have A04 cryptographic failure, A05 injection, A08 software or data integrity failure. Now we can start the machine. I already did that. Now let's start with the the cryptographic failure A04. So basically related to cryptographic failure. We come back to it now. Let's go now. It said, for example, failure make it yet another appearance in this was top 10 list. Basically, a failure happens when sensitive data isn't adequately protected due to the lack of encryption, fault implementation, or unsophisticated measure, basically using a weak encryption algorithm like MD5, SHA-1, or DES. So ECB, with that one, we'll find another room. An incredible example of this is an application or service ruling their own cryptography. This is really one of the dangerous things is you think you are smart enough to create the cryptography. Rather than using a well-established, vetted, and verifiably secure encryption algorithm. How to prevent cryptographic failure? Obviously use strict prevent, especially now with AI and soon quantum computing. Preventing cryptographic failure start with choosing strong modern algorithm. For example, we're talking about slow hashing but good, like Decrypt, Script, or Argon 2 when encrypting data. Avoid creating your own algorithm, instead rely on trusted industry standard. Never embed access credential, of course the key always protected, like in source code or config file and things like that. Now, for example, the practice is more, let's go before we go to the practice. For example, here he said here background moving down to position 4, so it means where it was before. Cryptographic fail in 21 was number 2. Now is moving number 4. So I think people start using. I think most software now updates they force you to use secure encryption. So and see the strong cryptography, leaking cryptographic keys and related error. 3 of the most common weaknesses in enumeration is the risk involved in use of weak pseudo random, especially online shop or something, like you don't get things like that. You can read about it if you want. This ROM. Let's go to the lab. The lab is more simpler lab. We're talking about home group encryption with a short key is easy broken XOR. All three encrypted note below use the same weak XOR cipher with a 4-character key. So we already have XOR That's not good protection. Then we have only short key with full character. Since XOR encryption is reversible and the key is short, you can, because the same key you use, you can brute force it, enter the correct key once decrypted all nodes. So we have nodes in our base 64, they tell us, and we're supposed to get the key. You just need to figure out the fourth character, and then his key information. The key is exactly 4 character long, and then it contains both letter and number, so you know the 4 is number. First 3 characters are shown as hint above. One key decrypt all 3 nodes. So of course the fixed use IES, GCM and strong keys. XOR cipher is weak. Short key can brute force, of course. Repeating keys pattern make it frequent and as possible. No authentication. Home group can lack the security guarantee. Let's go here, play a little bit before. Let's get to our friend. Because we know they told us is, no, not you. No, for example, we know it's a base 64 and we know it's an XOR and we know the key. So you can just come here. If you want to just guess that side is from base 64, and you can just say an XOR here, and you can just say, because we have the key said it's not hex, so it's UTF-8, we know the key start live, and they said it's number, so you start with a, you can see 0, it's a little bit, because XOR, because we know the first, you can see XOR was dangerous, but you can still get some values, but it's not correct, so it means it's not 0. You can try one, you can see it's clear. So meeting scheduled for tomorrow 3 p.m. conference room. So we know 1 is the correct one, because 2 you can see you still have some values, because that's how XOR work. So now we know the key is 1. We can confirm. We take another one, let's say the last one, for example, and we can see we got flag. So let's test the key 1 like in this room. So if we put key and put number 1 and decrypt everything, of course, and we have the frag. So basically Rome is simple. This one, I just tell you don't use you don't need hint here, it's just straightforward. Now the injection has been a long standing feature and top list. Let's see where the injection is doing. Injection 05. Injection no A5 injection, where is the injection was A3, went down to A5, so the injection now is down. Injection fall 2 spot from 3 to 5 in the ranking, maintaining its position relative to cryptographic failure. So we have that. An injection vulnerability is a system flaw that allows an attacker to insert malicious code. So basically that's what it is. If you want to read about it, here is of course we have straightforward. They have SQL injection, command injection, prompt server-side template, SSTI. So wherever you can inject in the system. The prevent ingestion, of course, is checking data input and just by ensuring the user input is always treated and trusted rather than passing directly. Instead, take element of the input equivalent. For example, SQL queries. This means using prepared statement, POD, and all of that things. Practical, for example, here they tell us we have some rooms in TryHackMe. You can try. Here we practice in the SSTI. They tell us an SSTI attack, practical, get the flag. So we can go to room number 2, and he already tell us what to do. In SSTI, he's just make a math. You can do any number. It doesn't need to be 77. So if I do that and plus that, and you can see I get 40. So getting number 40, it means So it means is an SSTI. Wherever you test like that, you find an SSTI. So when even SSTI, the different things we can do. These many payload you can. For example, it said you use Ginger template can access Python object where not sandbox, and then they tell us look for like config request cycle joiner and lipsum. So we can try a couple of things here. I have another one. For example, you can try lipsum. You can try any of them. They all work. So if I to lipsum global OSF open, and I'm just doing the ID, for example, render the payload. Now it tell me a root. I'm already in the machine. So for example, if I change it to ls, I can say docker file add hour of class and requirement and static template. So we can try the others to make sure it's working. For example, you can use the no, this is config. Okay, I didn't get the other one. I forgot where is it. You can try the config. We can try, for example, let's do ls myself like the root directory of the machine, and we get the root directory of the machine. All of them use a library, things like that. That's the result. Now if we want the flag, we can just, because we know the flag name, we can just cut flag.txt, for example, and we get the flag of the file, and that's it. So you can this is SSTI payload. You can say them using the feature rooms or something like that. That usually is standard. You can search for them and things like that. So this one is the injection part. The next one, the 08, the software and data integrity failure. Where is the software? This is the supply chain. Which A is doing TryHackMe? A08. Software and data integrity failure. So we're doing this one. Software data integrity failure continue at number 8, so it's not going with slightly clarified name change from software and data integrity failure. This category is focused on failure to maintain trust boundaries and verify the integrity of the software code and data artifact at a lower level than software supply chain failure. So we have this. If you're interested in that, for TryHackMe room, software data integrity failure occur when an application rely on code update or data assume are safe, like you install something without looking where you got it from, without verifying their authenticity, integrity, or origin. This include trust software update without verification, loading script, like you go to GitHub and you just download stuff. How to avoid, because of preventing this failure begin with establishing trust boundaries. Application should never assume the code update or key piece of data are legitimate. Okay, let's try to press it for CI/CD. For example, now we give us data, follow the steps and practice to generate and provide some malicious input in the web application. Recommend this. Okay, the insecure deserialization. This is more in PHP, not in what this room. And you have supply chain attack Luti. This is a room also is good to do. This is use Python to pickle a malicious serialized payload. This is pickle. Usually when you deal with Python, you talk about pickle. So here we have accepting and trusted serialized data without verification lead to code execution. This application has accept serialized Python object pickle format and deserialize them without verifying their integrity authentication. The attack vector is a craft malicious pickle payload that read flag.txt. When deserialize, the pickle model will reduce. You can get it from Gemini or ChatGPT. You know, they will write you the script. So this vulnerability non-integrity check, the script I'm using now is this one. Import pickle basis for process, ls this command, and then he print for me the one. So let me run that Python 3.9 p now you get this value. I will share the link to the script, or you have it in the room, or you have one similar in the room, you can use that one. So if I press that, no, this one give me ls, and sometimes when you do this, just view the page source if you want to see this one clearer. So you can go down. Where is my my input? Why it doesn't show me my that's funny. What is this? They're using I thought to get a nicer format. Any case, so basically you can see the root, you can see Docker file, readme requirement. Where is our flag? Oh, we have the flag.txt. So now you can go to your, because we know the flag now, so I can just say cat and flag.txt. I can save this one, and I just can come again and run it, and then we can copy that one again because I'm looking for that file. I can just paste this there and deserialize, and then it gave me the flag. And we good. Remember, TryHackMe also gave us the solution. Their solution to use eval open. They only use pickle and base64 and give you open, but this one is specifically to read files. So for example, open read, I'm not sure if we can run a command there, but it's fine. You can use this one or you can use this one. They're both the same things, they just, that part is different. I like this one because I can control it. It's easier to type. This one doesn't use eval sub process. That's why important sub process. Yeah, guys, that's the room. Thank you for watching. I'll try and make the other ones. So if you want, this is the OWASP top 10 RC1 version. Thank you very much, everybody, and have a good day.